Hello friends, you are watching Data Structures using C. All the videos are brought to you by Ankpro Training from Ankpro Technologies. So friends, in the last class we have learned the first type of searching technique, which is linear. So I hope you understood everything about searching and linear searching program as well. And today we are going to look at the second type of searching. So that is binary search, right? So what is binary search first? In the binary search, we are going to make the search list into two parts, right? We're going to divide the entire list into two parts, and we start by analyzing the middle element every time. So the binary search algorithm can be used with only sorted list of elements, because whenever we want to search an element using the binary search, it is going to divide the list into two parts uh, at the middle of the element. If the searching element is less than the middle, it will come in the left part of the list. Because it is already been sorted, obviously we know if the searching element is less than the middle element, it should be in the left part of the list, left part of the sub list, right? And if that is not happened, it should be at the right part of the list. So that is why we have to have the sorted list. If the elements are not sorted form, we go and make it sorted form, right? Yes. So next, the search process starts comparing the search element with the middle element in the list. So every time we compare the middle element with the search element. So that is the only thing we do here while we comparing the elements, right? If both are matched, then the result is element found. Otherwise, we check whether the search element is smaller or larger than the middle element in the list. If search element is smaller, then we repeat the same process for the left sub list of the middle element, right? If the search element is larger than the middle element, we repeat the same process for right sub list of the middle element. We repeat the process until we find the search element in the list, or until uh, we left with the sublist only one element, right? So we'll do this practically. So here is the code for binary search, and this is the list that has been given to us, which has 10 elements starting from the 0th index to 9th index. So this is the code, right? So high and low are the two variables. Low indicates the first index and high indicates the last index, right? And the data to be searched is 15. We're going to search the position of the number 15 in the list, right? See here, so low is the 0th index and high is the last index in the beginning, right? So it says while low remains less than or equal to high, you're going to repeat this code, right? And in the middle, so mid is a variable which stores low plus high by 2. That means mid stores the middle index, which is this. So now mid is representing the number 30 because low is 0, high is 9. 0 plus 9 by 2 is equal to 4, which is the quotient of 9 by 2. Okay, now mid is pointing to the 4th index. 30 is our middle element. So we check number of mid, that is number of 4 is equal to data. So this is our checking condition. Is 15 is equal to 30? No. If it is, we will set the flag 1, right? So at this case, number of mid, that is 30 is equal to data is equal to 15? No. So this condition is failed. So if the condition is failed, we can conclude that 30 is not our data, right? So in that case, we will check is data less than the number of mid. Is 15 less than 30? Is 50 less than 30? Yes, it is. So in that case, we will change the content of high. Now high is pointing to the last index. Now we will make this mid as our high, right? So since it is checked, now we are going to the left part of the list. So this is our high now. So we are already concluded that 30 is not the middle element, is not the our target element. So now we are going to target only these four elements. So the high would be 25. So now we will change high with mid minus 1. Now mid is 4. Mid minus 1 will represent 4 minus 1. That is 3 is our mid. So I will simply point to this end now. So this is my high now. Okay, so and I'm not going to change the content of the low, right? So again I'm checking, is low lesser than or equal to high? Yes, low is lesser than high. So in the next statement we are changing the content of mid here, right? What we are doing here, low plus high by 2. What is low? 0. 0 plus 3. 0 plus 3 by 2 gives you 1. 1 as the quotient, right? So now mid is pointing to 1. Here it is. So my middle element is 1 now. Okay, so let us check the condition here. Number of mid equal to data. What is number of mid? Is 15. Is 15 equal to 15? Yes, it is. So now flag has set to 1 and we will break out of the loop, right? So what happens now? So here it is the full code. When we break out of the loop, we will get with the flag set to 1 and number of mid is pointing to the first index, right? So if flag equals to 1, data found at location %d. So what is %d here? Mid plus 1. That is 1 plus 1 gives you 2, right? Data found at position 2, right? Yes, because this is the position 2. So we are printing that statement. Else data not found. So let's go for one more go. This time I will make this as 50, right? So let us start from the beginning, right? So currently mid is not pointing anywhere. Okay, that's fine. While low is less than or equal to high, low plus high by 2, 0 plus 9, 9 by 2 gives you 4. Again now mid is pointing 4, right? Number of mid equal to data? No, it is not, right? Is data less than number of mid? Is 50 less than 30? No. So if this gets no, else part will be executed. So here in the else part I'm changing the content of low, because so this time I'm going to look in this part. I'm going to look in these 5 elements. So that is why my high will be same as it is. My high will remain same as it is, but I have to make my low as this fifth index. So that is why I'm using mid plus 1. Mid plus 1 means this one, fifth index. I'm storing the fifth index in low. Low equals to mid plus 1. Now low is pointing to the fifth position. Obviously, because I've concluded that 30 is not matched with our data and data is more than 30. So obviously I have to look for the upper part, right? Or say the right part of the list, right? So is low less than or equal to high? Yes, obviously. So now make low plus high by 2. What is low here? 5. 5 plus high gives you 14. 14 by 2 gives you 7. Now mid is pointing to 7. Yes, right. Is number of mid equal to data? Is 45 equal to 50? No. Is data lesser than number of mid? 50. Is 50 less than 45? No. So we are changing the content of low again. So here we are pointing low one position next of the mid, right? So this will be my low now, right? Next, is low less than or equal to high? Yes, it is. So the content of mid will be low plus high by 2. 8 plus 9 gives you 17. 17 by 2 is 8, right? So now mid is pointing this 8th location. Yeah. So now both low and mid are pointing to the 8th location. Is number of mid is equal to data? Now yes, it is. Mid is equal to the data. 50 matched with 50, right? So this is number of mid and 50 is the data. So we will get the flag set to 1 and we are Here telling if flag equal to 1, data found at position mid plus 1. So mid is currently pointing at 8th index, 8 plus 1 gives you 9. Ultimately it is at the 9th position. I mean, as in the array aspect it is in the 8th location, uh, at our aspect it is in the 9th location. So this is the complete code for binary search. Please take this down on your book. Well friends, that's it for the class. Subscribe to our channel on YouTube, like our page on Facebook, follow us on Twitter, and join our group on LinkedIn. Thank you.